So good morning, everyone. My name is François Robida. I'm with the French Geological Survey, which is PRGM, which is maybe more known under this name than Geological Survey. So I'm not directly involved in some of the topics that will be discussed, but we are not very far from spatial planning because, of course, you have to take care of what is below your feet when you do some planning. So I'm quite interested in the discussion that we will have today. We have 4 presentations instead of 5 in the book. So it means that we will have probably more time for discussion at the end of the session. But what I would like is to keep the timing of 15 minutes altogether, presentation and short discussion for each presentation. And at the end of the session, we might have more generic discussions about the different presentations. So I will just for the presenters, I will try to give you a sign if you are not looking at the clock after 10 minutes, and try to keep your presentation within 12 minutes to allow at least 3 minutes of discussion after your talk. So the first presenter is the first presentation will be from Darko, about who is coming from the city of Zagreb. So Darko, floor is yours.
Good morning, everyone. It's kind of honor to be the first one, so thank you. The presentation is somewhere here. It's not. Do you know where is the presentations? Ah. Thank you. Thank you very much. For the start, I would like to just tell you a few words about my co-authors. Of course, maybe you know Professor Vlado Cetl. He is from JRC, European Commission. He's now hosting the other session. And Tomislav Ciceli from State Geodetic Administration of Croatia, a national contact point for NSDI in Croatia. So we have this Croatian team, which is really on 3 levels, on European, on national, and me, myself, I'm working for the City Office of Strategic Planning and Development of the city of Zagreb. So the content is like, I will go through this relationship of the cities and INSPIRE shortly, cities in Croatia and SDI, then through to the local level, to the city of Zagreb, SDI, and finally to the planning, to the strategic information concept that we are now developing. When we talk about cities in INSPIRE, of course, this is well known, but maybe it's not a bad thing to stress that the local city level SDI is driven by the needs of administration, usually like in Zagreb. Case and citizens, of course, needs of citizens more than needs of legislation, and usually consist of more detailed data sets than maybe sometimes national or European level. It is, of course, connected vertically to national and EU level, and the role of the cities in INSPIRE directive, they are defined like public authorities, of course, these local level authorities. We try to use the resource browser of the INSPIRE to do some research on the cities in INSPIRE. It is not easy. This is not fitted to this kind of search. So we only found that with query to responsible organization name, the city, Stadt and Stadtverwaltung. This is, of course, English and Deutsch. and we found out the dominating spatial data themes for the cities in these resource browsers are, of course, land use, like INSPIRE itself, and area management. So it's interesting for the topic of spatial planning. Within the National Spatial Data Infrastructure Act, the NSDI subjects are defined as public authorities whose competencies are maintaining of spatial data. And of course, public authorities can be local level authorities like cities and municipalities. In Croatia, we have 128 municipalities. It's a small country, of course, in European scale, but we have 128 municipalities with city status, so we think of them as cities, although they are mostly small and medium-sized cities and really towns. On this map, you can see the distribution of urban network in Croatia. We have 4 core areas of urbanity, and the other part that is not so urbanly developed. There are, of course, large differences in financial and professional capacities, especially considering management, knowledge, management of spatial data, and only at the present moment, only 6% of cities are within active in NSDI, so it's really small number. It is a little bit easier for us to research the NSDI level of involvement of cities because there are not so many of them. So the 20% of the NSDI subjects are local level in Croatia, and around 14% of the resources are from the local level. When it's come to city of Zagreb, data resources, it's around 8% of all data resources in Croatia, but it is almost 60% of all local SDI resources from several data teams. So it shows us that the capital city is, of course, the leader, and maybe too much at the moment. So the smaller towns need to be more involved in the development of NSDI. Now we're going to a local level on the city of Zagreb SDI. We call it ZIP. It's an acronym, of course, for Zagrebačka infrastruktura prostornih podataka. It's spatial data. It gathers spatial data from city administration, from city utility companies and institutions. This dissemination period starts in 2004 with WebGIS, and then GeoPortal was established in 2012, and finally mobile application and this year. Initiative for this project really started from real estate sector within the city administration and spatial planning department. We have SDI coordination on the city level with representatives of city offices and institutions, and the leading authorities for the spatial data infrastructure within the city of Zagreb are Office of Strategic Planning and Development, like Planning Department, Office for ICT, and City ICT Company. It is really not only city company, it's half city and half state company. This is kind of a scheme of Zagreb SDI. I found it a flexible organization, and from this flexibility there's resilience, but it's kind of organic kind of management. In each role we have many stakeholders. The SDI coordination, city offices, and needs comes from also from research and from legislation. Data sources are, of course, city offices. City IT company is also managing the data sources, and of course outside data providers. When it's come to financing, it's Office from ICT, it's paying for maintaining the system. Office for Strategic Planning for development, overall development of the system, and the city offices for specific development of the system for their own needs. For example, Office for Agriculture or Office for Energy, etc. Application development and database management is on the city ICT company, and sometimes from some other providers. And finally, users, of course, are city administration. This is the power user, and business science, especially business and science, of course, in real estate, in architecture, planning, engineering, all of kind, environment, and etc. And finally, the citizens who are really aware of the application and use it very much. We have around 2,100 users per year, and as I said on the last slide, it's used for all spatially oriented activities in city administration, from planning, land management, and so on. Also, the NGOs are users of this infrastructure of ours. And finally, strategic information concept. We find this like a new organizational approach, which is connected with the SDI, of course, and the spatial planning. This year we started, this last year in legislation, this year practically. Within the City Office of Strategic Planning, we founded the sector for strategic information and research, and it consists of two departments. One is for spatial information, another is for statistics. We found this really in trends today because it can give better information basis for the planning and management of the city, not only spatial planning, but also economic planning and everything else. We just started with this, so there are many things to do. One of the results of strategic information concept is a new way of dealing with strategic city projects with spatial and statistical analysis, like semi-standardized products, with land use analysis, population distribution analysis, and other statistical information about the population and the apartments, which is quite important, and social infrastructure. These are three main data sets for us at the moment for this analysis. And analysis results with guidelines for planning and development. For example, if you can see this area here, it's a brownfield development site in the city center by the railroad, of course. And if you can see, the population is decreasing here, so we have to have new apartments. We have a small household, so we have to bring the young population, to bring the kids, so it have to be large apartments. Of course, some social infrastructure. This is the other example of area that is relatively old population, and this is area for the new park. And we are thinking about putting in the park some of the social infrastructure, like for the older people. So this is really a concept. Of course, all of this is supported by the SDI, and SDI really gives initiative for people in the city administration and broader to open the data. This is the most important result of the SDI in the city. And I come to conclusions. So the cities are subjects to INSPIRE and to NSDI, of course, but from our point of view, not involved enough. Croatian cities participate with 14% of all NSDI resources, but Zagreb from this number is 56%, which is too much, of course. Of course, Zagreb City SDI is largest in Croatia and initiated from real estate spatial planning sectors. We have a flexible organization structure with coordination body led by planning department, which is interesting from the spatial planning point of view. And City Geoportal is central and inevitable point for city administration, for business, science and citizens, and SDI helps development of the new spatial analysis approach in city planning. Thank you very much. these are contacts.
Thank you very much for this interesting presentation. Do we have time for 2 or 3 minutes for questions? I have one. You mentioned that the cities are not involved enough for the time being. How do you see what could be the way to have them more involved? Do you see, at least in your country, the example of Zagreb could be of interest for, I can imagine, for smaller cities?
It is a hard question for me because the cities usually don't have enough resources for the NSDI, from my point of view. The large cities maybe have, but maybe through some organizational activities. At the moment, national contact point for Croatia, NSDI of Croatia is doing something for the regional coordinators, or
maybe I can answer. Also working on that. So in Croatia, in first phase, we covered national level of NSDI subjects, and now in second phase, we will be more focused on those subjects on the regional levels, cities especially. And now we prepared some projects to go directly to them and try to involve them more concretely in NSDI. But like Darko said, we are expecting problems with human capacity, financial capacities, but we hope that through some project activities we will manage to solve that. But for now, they are somehow in the, except some good examples like city of Zagreb and maybe some few other big cities, they are more or less, out of the NSDI for moment. But we hope that in the next phase or two-year period, we will involve them much deeper.
Okay, thank you. With the microphone, please. And if you can introduce yourself, please.
My name is Luka Jovicic. I'm working for the GDI office in Skopje. I would like to know which amount of data on the City Geoportal is open data, accessible to all subjects, let's say, and did you measure reusability of the data? I don't know, maybe for some NGO users, for startups or other examples. Thanks.
Yeah, we are still not measuring it, although we have some plans for this year to update the system with this function. But when it comes to open data, of course, we have some WMS services for the data sets, but that's all at the moment. Although we have other channels for distributing the data in classical ways. It is open from our office, all the data is open data.
Okay, thank you very much, Darko.
Thank you.
Thanks again. So let's move to the second presentation by Michal Met from the Czech Technical University in Prague. So, Michal, the floor is yours, if you can find your presentation.
It won't be a problem. Hopefully. Let's go. Yeah. Okay. Okay, my name is Michal Met, and I'm from Czech Technical University in Prague, where I'm doing my dissertation thesis on topic of extended INSPIRE within the context of spatial infrastructures in the Czech Republic. And I really don't know why I'm in the section about spatial planning. So what I'm going to talk about? I'm going to talk about extending of INSPIRE data. So for the first, as the first point, let's look at the 3 points of view on INSPIRE data. We have, on one side, we have the INSPIRE, that's the angle pineapple on the left side. And that's somehow who tells us what he wants from us. So we have some implementation rules, we have some data specifications, some basic rules on which we have to agree, and we need to have some common basis, because the goal of the INSPIRE is to make interoperable or harmonized data across the whole Europe, and in every country of Europe we have different rules for different data, so we need to find the basis. On the other side, on the right side, we have NMCAs, National Mapping and Cadastral Agencies. So it's their goal to implement INSPIRE. But on the other side, they have other goals. They also have to maintain some national data and national infrastructures. So for quite a lot of them, they see INSPIRE as an obligation, as something which is forced to them from above, and they have to do it together with all other duties they have at home. And on the bottom, we see users. Users are quite confused. What kind of data are we getting? Because most of them are used to national data sets, and out of sudden they get something else from INSPIRE, and they really don't know what to do with that. So is it somehow better, or is the content different? So they are quite confused and they don't know what to do. All they want is to have some useful data, and they really don't care if it's from INSPIRE or from national sources. So let's look at the three types of data. We can have interoperable data in the context of INSPIRE, which means that we have data, they are conform to standards. We have all obligatory requirements, then we can call it interoperable data. But in the end, it doesn't have to be really useful, because we don't have any connection between the data sets, so we can move to harmonized data. Harmonized data have extended attributes, and we know much more about this data. They are connected to each other. And what the users really want is useful data. They really don't care from which source it comes, but they need the data to be complete and to be as rich as possible. But on the other side, it has to be somehow standardized to make it easy to work with. So as an example, we can show INSPIRE dataset. I'm working most of the time. I'm working with 4 teams of INSPIRE. It's cadastral parcels, addresses, administrative units, and buildings. So I call it administrative teams. And in this topic, we can look at the cadastral parcels. If we have cadastral parcels as interoperable data set, we have the boundaries, we have polygons of parcels, we have some labels, and we have some national references. That's basically all we have about all we know about the cadastral parcels. But if you look at the national data, on the national level, there are some differences because, as I said at the beginning, INSPIRE is the basis. And if we have 29 countries which are trying to implement INSPIRE, the basis is really simple. It's only the basis of all datasets. So this is how it looks in the Czech Republic, the national dataset. It's much richer. We have much more features, much more attributes, because Czech cadastral law has some history, and it contains a lot of stuff, and also the users in the Czech Republic, they want all of this. They are not satisfied with this. Yeah. But on the other side, INSPIRE has also a lot of pros, not only cons. The pros are it's standardized. It has a standardized format. It's using standardized services. It's really easy to download the data. It's really easy to manage them, and best of all is that in all member countries of European Union is the same. That means that if I make some application which is suitable to read the data of cadastral parcels in the Czech Republic, I can do the same in Germany, Spain, Norway, etc. So in this particular case, we need to extend cadastral parcels in the Czech Republic somehow. And we try to keep the structure. We try to keep the standards, which are the good things about INSPIRE, and we just need to extend the content. So what do we have here? We have geodetic points, we have some easements, we have map symbols, and all of it has to be extended into INSPIRE dataset. So we have designed a schema. This is like application schema for cadastral parcels extended, which is using the basic schema on the top and extends it for new features or extend the old features. For example, cadastral parcels and cadastral boundaries are extended for the new attributes, and we have quite a lot of new feature types like easements, geodetic points, other features. We also have original geometries because INSPIRE allows us only to have line strings. But in Czech cadastre, there are also arcs or circles, which isn't allowed in INSPIRE, so we created a new feature type. Just a quick overview how it looks like. We are coming. Does it work? Yeah. We are coming from the cadastral parcel feature type, which comes from cadastral parcels application schema, and we add new attributes to it, like some connection to buildings, some map symbols. We also have a land type coming from Hilux to each cadastral parcel. We know land types, we know land use, we have links to original geometry, etc. The other possibility is to create a new feature, like example easement. And the easement doesn't extend any of existing features in INSPIRE, which means that we have to create this as a new feature, and to follow the rules of GML given by OGC, it has to be at least the extension of abstract feature type. But all of the attributes we have here are new. So we are trying to keep it in the structure of INSPIRE, which means INSPIRE ID, begin lifespan version, and geometry, and the rest is specific to the topic. So how to implement it in the end? While we have the model of application schema in the Unified Modeling Language, we create an XSD schema to be validated from. And we are doing the same like during the implementation of INSPIRE. We need to be conformant with INSPIRE, which means we have to be conformant with OGC standards, and they are referring to ISO. So the implementation is in the end the same. Here's the quick topic of a quick show of UML model. On the top right, we see this is the original cadastral parcels application schema, and the rest here is the extension. Quite interesting thing about it is map symbols. So map symbols is cadastral parcels doesn't look like that, but the map symbols were quite difficult to implement because we need a new feature type for it. Because for every parcel, you can have more map symbols. For example, arrows. If the parcel is narrow, and you need to put a map symbol or number into it, it's too small to be visible, so you need to put an arrow there. And for every feature, you need a new geometry. Other really important thing about the extensions is links to the other teams. I think it's one of the most important things about INSPIRE. If we have data which has the same structure, which are following the same standards, and we have divided them into more topics, we need to reuse them by connecting them using links. For example, in cadastral parcels, I can have link to a building which is standing on that parcel. I can have a link to the address point which is connected to the parcel, and I have also links to the upper level like municipalities or cadastral zonings. So this should be done using links. And what about the results? We started with the creative process. And inspiration and work are the crucial parts of it. But as all of you know, it's they are not the parts which you spend the most time of with. So after 6 months, more or less, we have developed the testing. We have developed the extended model. We have it transformed from the database, and because one of the developers from the company which is delivering us a solution has a vacation for the last 14 days, we weren't able to run the alpha version until now. So maybe next week you can find the alpha version of Cadastral Parcels extended. We have stored it in the database, which is a standard model of oral services, and from the database you get the map, which follows the national cadastral law. It's not the map; it's vector data which can be visualized this way. It contains all the features. That's all from me, and I hope that you have some questions.
Thank you, Mitchell.
Hello.
We have a question.
Thank you. But I have a question because I was in the team that make the specification of cadastral parcel. We study all the system, and we knew that it was impossible to harmonize all the cadasters, so we only harmonized the minimum possible. So what sense has to do the extension in Czech Republic, the extension in Spain, that it will be totally different? And because we were thinking the same, to extend the model, but what is the sense to extend? At the end, we transform it and we give the data of the INSPIRE as another service, but we didn't change all our system because it has a lot of implications. What sense has to have the extension in Czech, the extension in, if they are not going to, because the specification was done in 2 steps. We put the cadastral reference, and then you can go to the data through the cadastral reference of every country. But the location is what is in INSPIRE, but the other things that they are totally different and very legal, what sense has to do an extension?
No, I think that the sense is that local users don't want to use INSPIRE if it doesn't contain all the information they want, and all they want is the national information.
But
and
this is not INSPIRE. The national information is not INSPIRE.
no, INSPIRE is really INSPIRE is really easy to extend, and I think that I get it the way that it was meant to be extended by the national needs. It's also written in the implementation rules that how to extend INSPIRE. You just need to keep the basis of the INSPIRE and document it properly. That's all. And in the end, it's much easier because you know that the structure and the standards used are the same everywhere. I think that if I extend INSPIRE, it's still INSPIRE.
Another question?
Thank you. Amitka Faugnerova from Czech Environmental Information Agency, being the national contact point for INSPIRE. I might add just one comment, and that's what the Czech National Mapping Agency is doing is basically being discussed now in other topic groups. So let's say protected sites from the nature point of view, protected sites from the monumental point of view, and so these groups of stakeholders are willing to let's say standardize their data according to INSPIRE, but at the end they would like to avoid to keep 2 separate databases to satisfy the users from 2 separate sources. So this is, from my point of view, the reason for the extension. It fulfills INSPIRE and at the same time it satisfies the national users. But so this is just a comment. Maybe Michal might add something to that.
I think that is, this is shown in this picture. We have users, and the users are confused. They really need one source of data, and they really don't care if it's called INSPIRE, if it's called national services. But if we have INSPIRE, I think it's better to use INSPIRE. So make it comfortable for the users and extend it to every needs they have.
Very last question.
Peter Parslow from Ordnance Survey in United Kingdom. So we've extended a water network, road network, and geographical name schemas for what sound to me like similar reasons. Geonovum in the Netherlands sponsored a piece of work by a company that was done by a company called We Transform to look at mechanisms for extending INSPIRE, and they've established a sort of best practice registry. And it sounds like you could put your thing up on there as an example. I think it's the biggest extension I've seen so far. Are you aware of that project? Or?
Yeah, I was talking to Thorsten, right? From
yes. Okay, that's the man.
And I probably try to. We were talking that I'm definitely going to add this to the register, but once it's done.
Okay. Thank you very much.
I'm really.
Oops, sorry.
I'm really thankful, and I'm really willing to give my best practice to every other people who wants to extend. That is the point.
Okay. Thank you. Okay. We'll have the third presentation from Germany, from Hamburg. So Kai Uwe, floor is yours.
Yes, I will tell you something about our German approach to transform German spatial land use planning data to the planned land use standard from INSPIRE. First of all, I'd like to introduce my colleague, Mr. Joachim Benner from the Karlsruhe Institute of Technology. Unfortunately, he couldn't join the conference. My name is Kai Uwe Krause. I am the head of the coordination side of spatial data infrastructure of the city-state of Hamburg. I suppose you heard about Hamburg, but anyway, I'd like to bring you some brief information about Hamburg. Hamburg is a city-state, one of the 16 states in Germany. In Germany, we have 3 city-states besides Hamburg. Also, Berlin and Bremen is a city-state. It is both a municipality and the federal state of the Federal Republic of Germany. And so in this case, we also have ministries. And Hamburg is it's near by the North Sea, but not at the North Sea. You can see our river Elbe. So you've got to about 100 kilometers from the North Sea, far away. So Hamburg has 1,070,000 or 1.76 million inhabitants. And so it's the second biggest city in Hamburg after in Germany after Berlin. So now I'll give you some the main challenges of Hamburg, or some challenges. Hamburg is a growing city. Approximately, we will have 100,000 new inhabitants to the year 2030. We have a high demand for new homes, new working spaces, and in this case, we have the political requirement or from the states, the chancellery gave the administration the political requirement to build, to provide planning acts for 10,000 dwellings per year, and planning processes shall be finished within 18 months. This means that we implemented an integrated digital planning and building process chains from the digital legal land use plan. This is an object model called XPlanung. I will present you further on, to electronical assisted processing of building applications. This is another German standard, XBau. The X means XML-based standards. To building information modeling, it's based on EFC files. So these are these are the challenges, and now for the development of the reasons for the development standards. Until now, we've got several participants in planning processes: the authority, neighborhoods, municipalities, planning agency, real estate agency, and they have always to export data from one agent, from one actor to another actor, and we don't have a standard until now, and in many cases only PDF files are exchanged between these actors. So, because of this, we developed a standard since 2004. In some of EU government strategies. The first one was Deutschland Online, but it was several more. So some goals of XPlanung. XPlanung is a semantic data model describing the geometrical and geological content of spatial plan, and it's independent from the geographical representation, and it's an object-oriented exchange format based on GML. The one goal is to support electronical assistant processing of building application as well as a standardized data format for e-participation platform. And one goal is to store all the legal land use plan in a one uniform semantic structure in one database. And this is one goal I'm talking about today. We've got if all legal land use plans have the same data structure, we only need to define one transformation rule. From the German planning legislation from legal land use plans that are all in the data format of XPlanung GML, and we've got to define one transformation for INSPIRE planned land use. So, and XPlanung is an object model, and the exchange format in this case is an XPlanung GML. Yes, and I think I talked about this. So now you have some brief screens. XPlanung is implemented until now in several applications in Germany. With one application based on AutoCAD is, for example, based VS Land. And this is a sketch of the legal land use plan in Hamburg. This green area is designed as a public green space. It's a playground, and if we export this data as XPlanung, we can import it in another application based on Esri, on ArcGIS, on its GeoOffice. We can import this file, and the green area is still a playground. We are in the last 2 or 2.5 years, we digitized all legal land use plans. We've got 2,600 plans in Hamburg, conforming to this XPlanung model. It stores them in one database, and now these data can be provided as WMS and WFS services. And we had used the degree framework for this. You can see in this screen, you can see all legal land use plans. They are not the whole area from Hamburg is not covered with legal land use plans, because the areas we don't have plans, they are rural areas of for example, in the middle of Hamburg, it's a harbor. There's a special planning law, and we are not responsible for this planning law for the harbor. And now, and XPlanung is, I told you, it's a German standard. I hope so. It will be probably adopted in the next months, beginning in October, as a standardized digital data exchange for spatial plans by the IT Planning Council. This is a central body responsible for national IT cooperation in Germany. So this is an example for XPlanung used in participation processes. And now I give you an overview how to, or some idea how we can transform this data to planned use data to the planned use data model. And I take an example. Yes, you had. I think you had. You know this landmark. It's the Elb Philharmonie. In this Elb Philharmonie, for this Elb Philharmonie, there's a legal land use plan. And now we've got some, for example, there are some regulation about the permissible lot coverage. In this place, I think yes, permissible height of this construction is about 97 meters. For example, in the brown area describes it as a core area. And now I briefly show you the workflow. We've got the application, export the data. We had defined transformation rules, and there's a black box. It's an application. It's called from Mr. Benner. He had developed. It's a toolbox. It's transforms the data. The transformed data are imported with its the WFS T service in a Postgres database, and this data are again provided as WFS and WMS services. So, kon halt Wording rehat Salz, we was able to process valid data sets, and we use the concepts of planned land use. For example, the dimensional indication values can be represented. For example, floor space index, cubing ratio, or the height of structure, and we can also describe the ordinance value for example, the specification planning, the plan preparation process. and we use the zoning elements, one or more equivalent helix values can be used, but we don't use the Hilux presence concept. So, some screens. This is the original XPlanung BMS service. We've got some textual regulation, for example, and they can be transformed as well as in planned land use. All these texts are in this structure, for example, and you can find them as here again. And for the zoning elements, for example, this is a core area, and so this is a problem in our data model in planned land use. The core area with a mixed uses can't be represented with one value. So this core area is described as cultural, entertainment, and recreational service, as well as commercial services and finance and professional services. Is not really right because there's a hotel inside in this building of the Philharmonie, as well as some housing areas. But we define this transformation in from the core area to planned land use in the transforming rules, and this is a missing in our INSPIRE data model that we can represent core areas, for example. So this is now coming to the end. XPlanung supports the implementation of digital e-government urban planning process change, as well as the implementation of INSPIRE directive, especially for planned land use. And thanks for your attention.
Thank you very much. Just before the question, do we have the last presenter in the room?
Yes.
Okay, very good. So, questions? I have one provocative question. I take this the privilege of the chair to ask provocative questions. You describe this new standard in Germany, which seems to be quite rich and powerful to implement the e-government application and so on. So it's good to see that you are able from this to be compliant with INSPIRE, but what is the interest of the INSPIRE services in this context in Germany?
What is the interest? Yeah, first of all, we've got our local law because we have a city-state of Hamburg, so we've got the law, the INSPIRE law in our context, and so we have to provide these data as planned land use data. So.
Okay.
But I think the XPlanung GML model is richer than the INSPIRE model.
Yeah. Okay. Okay, thank you very much again. So the last presentation of the session, which, as I said at the beginning, we have 4 presentations and not 5 like described in the book. So we'll be from Poland. So, and if you can find your PowerPoint, that's fine. Floor is yours for 12 minutes presentation and then some questions.
Yes. So, hello everybody. My name is Jan Pryzowicz. I come from Poland, from the National Water Management Authority. Today I will show you a presentation that I prepared along with my boss, Mrs. Agnieszka. Unfortunately, she couldn't come, This presentation is about trust and its consequences if there is too much of its trust. But first things first, some history and an introduction to the topic. So my big boss, the president of the National Water Management Authority, is obliged by the Polish water law to gather and present hydrographical information within the water cadastre. On the right side, you can see that we expect to have 4 spatial data sets concerning the hydrography by the end of this year, because we have the INSPIRE deadline coming in September, not in September, at the end of the year, before December. Currently, we have 2 maps: the map of hydrographical division of Poland in scale of 1 to 50,000, and map of hydrographical division of Poland in scale of 1 to 10,000. We are not very much creative with our names, and based on it, we will create INSPIRE hydrography in scale of 1 to 1,000 and 1 to 50. So the first map, the oldest one, which needed to be prepared because we signed the WFD directive. It was the first version, the 1.0, was designed in 2004. It was a digital version of old, maybe not old, but military maps that came from the topographic board of general staff of Polish army, or something like that. We used the topographical maps in scale of 1 to 50,000, which were supplemented by the diapositives of water network maps and terrain sculpture maps. The latest version came in 2010. It was an update based on the orthophoto maps provided by the head office of geodesy and cartography in Poland. We started to use the new sources of information. So as you can see, the total length of the river network is more than 140,000 kilometers, with nearly 30,000 elementary catchment areas. Our maps are the only maps in Poland that contain the information about catchment areas in the whole country. And elementary catchment area is a catchment area for a segment of river. I will show it you in the map in a second. Oh, and here we have the overview of what kind of information we have on our map. So we have the elementary catchment areas. Okay, so we can see here we have river sections, and they have their own elementary catchments. We have the main layers for rivers divided in sections. Hydro nodes which give us information about the changes in the characteristics of rivers. White rivers, which is a kind of polygon for rivers which are wider than 5 meters, but it's more like a background layer. We have indistinguished rivers because we decided that we had information about some kind of water courses which didn't comply our standards for the main rivers, which is that they had to be wider than 1 meter. But we didn't want to lose the information, and we have it as a background layer. Then we have lakes, also indistinguished lakes, so the same situation like indistinguished rivers, watershed nodes, and the old school map sections for a topographic map in scale of 1 to 50,000. This is kind of a very important set because everything that was done to this moment for the water management in Poland was based on this map. We designated all the water bodies that are for the first and the second cycle of the WFD, the regional water regions, which are areas where our regional water management authorities are working on. But as I said before, it was digital version of all the military maps, and with time the new sources of information started to emerge, and we were wondering what was the actual credibility of the data that we were presenting. Should it be actualized? And then in 2011 the new sources emerged. We have the digital elevation models, orthophoto maps, just a lot of stuff was going on. So we decided to launch a new project. It's the MPHP10. The first version emerged in 2013, and as you can see, we changed the sources of the information for a new data set. We use the digital elevation model to designate the catchments. Use the database of topographic objects, which is a huge database covering whole Poland, containing a lot of different information about rivers, roads, buildings, land use, and everything, as a source of the geometry for our rivers and lakes, because the information was coming from down below. So we were sure that the regional authorities know what they have. We also use topographic maps in scale of 1 to 10,000, orthophoto maps, and the old map of hydro-graphical division, because when the project was in progress, the database of topographic objects wasn't complete. It was more than 90% of the country, but there were some gaps. And for names, we use the State Register of Geographical Names, and in effect, we have a more precise map which extended the total length of rivers by 10,000 kilometers, and we have additional almost 4,000 elementary catchment areas. So the last version came up in 2016. It was the beginning of my work at the National Water Management Authority, but it was more a patchwork. When the product was released, we were sure that we have the best quality of information available. But like with every product that there is, you need to revise your way of thinking when our colleagues from other departments, from other authorities, from institutes, researchers, and local governments told us that there were mistakes, errors, and inconsistencies. But Phil, you can see that the model didn't change very much. We liked it. Actually, the model was accepted by the users. But the thing is that back in 2013, we first used it as a reference data set for our project with a very fancy name, because we like really, really long names for our projects in Poland. And it went well in some parts, it didn't in others. This project was aimed to designate a new list of water bodies for the first cycle of the WFD. All types of water bodies, river, lakes, transitional coastals, with new designation of types and some aggregation, disaggregations. And during this project, questions started to emerge. We have three main groups that came up. First of all, it's occurred that our map has a heterogeneous methodology of geometry determination of lakes and water reservoirs. So sometimes in some regions, because it's different in different regions, because the information came from below, so there was no coordination. But the job was done up, but you just don't have the staff and the resources to verify everything there is. So first thing first, the border line that included the rush communities, which is like a proper approach to designate the lakes. Second method, which excluded the rush communities, and the third one, which combined both methods within the same lake. As you can see, for example, Grabowskie Lake is the first case. Mąkolno Lake is the second one, and you even can see that some parts of the water weren't taken into polygon. And Vigry Lake, those two pictures here, you can see there are both methods within the same reservoir. And we are very not happy with the effects. We knew that we had to act quickly, because the first cycle is coming like in a few years, but you have to do all the job before. And the second thing was the designation of shoreline, additions of rivers, canals, islands, with no strict methodology. For example, for islands that all islands that have surface bigger than 100 square meters, for example, should be included or not. And the third thing is unreasonable cases of lake basin division into smaller basins and or lack of subdivision in cases which are hydrologically justified. The time was running out, and we knew that we weren't able to do everything. We couldn't make a huge correction of a data set that covers a whole country, and preparing the MPHP10 took us 1.5 years. So it's quite a short time to do it, and probably maybe these are the effects of just rushing things. But in the end, we decided to launch a new project, which started September this year. It's the analysis and update of management units with the consideration of MPHP10. It's a two-stage project. The first stage ends in October. So first, we make the MPHP correction based on the issues that we know related to the lake layer and other layers, because when we change lakes, we just must make adjustments to all the other layers. Then the network must be complete. And then at the second stage, we'll make adjustment to the list of surface water bodies with determination of new regional water management authorities, river basin districts, and water regions. One of the reasons that made us do it was that, in effect of designating the new list, around 61 lakes lost their status as water bodies. And this made us think. And some people were saying that, well, no, we have more precise information right now, so maybe it's how it should be done. But on the other hand, we had cases when on the old map, on MPHP 50, for example, lake had 60 hectares of surface, and now it had 20. So how come lake shrinked 3 times? And but we started also to wonder where to gain information. What sources are the best to do the job? And the idea is to use we started to actually to do it, to use the data from the Copernicus Sentinel-2 mission within the Copernicus program. We are using NDVI index images provided by a private company based on the images provided by the Sentinel-2A program, which was launched in June 2015 and commissioned in October. So it provides us with really up-to-date information about lakes. As you can see, we have one of our lakes. So we are first checking the NDVI index, then we are making corrections. Experts look into the effects of modeling, and in some cases, if after the NDVI analysis we have a lake that has a surface between 49 and 51 hectares, and in Poland we have a rule that we designate as a water body every lake that has more than 50 hectares, we make additional analysis of the outcome using the digital sculpture model. And this project, we don't check every single lake. We check lakes that we have that have surface bigger than 10 hectares, which is around 4,000 lakes to check. And we are going to do it in 1.5 months. And I was hoping that I could show you more, but we have some setbacks at the project, typical stuff. But as you can see, on the left side is Szczecińskie Lake before the analysis that we had currently have in the MPH10, which is below this threshold value for water body, and this is the lake after the analysis with use of the digital sculpture model, and now we are sure that we have most accurate information about it, and it will be designated as a water body. So, just not to take it too long, thank you very much, and I hope that I will be able to show you some more information in future and the results. Thank you.
Thank you. Questions? It's all about the quality of the data and the use of data. It's not only about the process to deliver the data, but make sure that we have something which is consistent.
Yeah, the thing is, you need to, in Poland, like we are quite kind of big country and we can't check everything. So you just have to release the data. It must begin to live, and people will give you the information. They will check it for you. And this is the proper approach, and this is the one of the best things that we have in the INSPIRE directive. But we should always remember that INSPIRE is about not only interoperability, but also about providing quality data. And we must make sure that the state registers that are the sources of information for INSPIRE have the top quality. It's like never-ending work. So, thank you very much.
Thank you. We have, as there is no fifth presentation, we may have some time for further discussions. I think these presentations were quite interesting, showing that we are now in the process really of using the INSPIRE, and the example that we have seen for cities of Zagreb and Hamburg, and this presentation about the water bodies and hydrographic data show that I think we are a step ahead, and now we have to check the implementation in front of the real use of the data. Any reaction in the group in the room about yes?
Lena Hallin-Pihlatie from the Finnish Environment Institute. I'm also the facilitator of the land cover and land use cluster. And I'm very happy to see that there are some examples around for the INSPIRE planned land use, as I haven't seen any sample GMLs and WMS and WFS so far. And so my question would be to Kai Uwe, would you be willing to share these links, WFS, are they open, and where can I find them to share to others to follow your good examples?
Until now, they are not open because it is a question about the quality of the transformation. We are not sure about it of if our transformation or mapping table is right. And we have in the next week we have a working group earlier we have a working group in Germany that is developing or finding these mapping tables. And after we've finished these mapping tables, we have another quality step further on, and then this data will be free. That's no problem. But until now, there's only they exist as a WFS and WMS service, but only in the intranet from Hamburg.
But it's just a matter of months.
Yes, and I can show you. I think we have a meeting until now and today.
Yes.
So I can show you. I have my notebook with me, and I can show you.
So for everyone, if not everyone knows, so there is a thematic cluster meeting for the land cover and land use cluster at the INSPIRE booth at 1 p.m. And if there are many of us, we will go to the AC, the Commission's INSPIRE room. Otherwise, we will stay for 1 hour at the INSPIRE room. You're welcome to join.
I have also questioned regarding XPlanung or XPlanung. Why not go the Czech route and extend the INSPIRE standard? Why come up with your own standard and then map it to INSPIRE?
So maybe this is a question of time, because we started our XPlanung project in 2004, and yes, and I was also part of the technical or making working group for the planned land use data model. But this working group started, I think, 2010 or 9, and so we have a furthermore step on, and knowing that the INSPIRE planned use model won't cover all our needs in special German law, but there is a question about maybe in the future that the land use model can be extended, but until now we've also some problems with to have really clients, WFS clients, that can interpret this complex INSPIRE WFS planned land use data model. And it's a little more easier to interpret our XPlanung data model.
So reaction to a different part of something that came out in both Hamburg and Poland's talks about, so more in sense in Hamburg's answer more recently, is about data quality and the need for continuous effort to improve that quality, and that therefore that needs a continued sort of sustainable business model. Now in Hamburg's case, it's because the data is essential to the running of the city, so the cities and the developers and everybody are going to be funding it, whereas in Poland it sounded that might be a little bit more of a problem. But I suppose that's just to make a pitch for that. So when you're building whatever it is you produce to produce some data, make sure you build something that has a sustainable way of keeping that data improved. If you put data out there and people tell you things that are wrong with it, it's awkward if you haven't got any money left to fix those things. And okay, I said before, I'm from Ordnance Survey. We have been caught out like that sometimes, where we've put data out and taken years to fix the errors, and we're trying to get better. But so it's not so much a question, it was a kind of reaction to something I saw across two of the talks about data quality and the need to be continually improving.
Yes, I think this is a very crucial aspect of the system. We cannot define a system where we deliver a data set forever and do not change anything. So we have to find, as you said, business models where we have some guarantee that the improvement or the update of the database will be done by the original provider or maybe by other contributors. But this is sometimes quite a complex thing. Okay. Any more discussion? If not, I would like to thank you again, the presenters for the good, very nice presentations, and all you for the quality of the discussion. Thank you again.
I don't know which one it was, but look, they were just 4, and yes, it was took place. It was the last one, yes. But he's already gone.
Okay, thank you. Sorry, the video of the session, I don't know, yeah, they will be available after. Yeah.
XPlanung is the